I just realized I didn't double check this. Ah! Ugh, why is that not working? Ah! There, better. There we go. All right. So, that being said, let's go. All right. Class.
Yes.
Thank you for everyone that's actually paying attention. You're trying to turn in homework? Right now? Okay. But can it wait till at least the end of this? Sure. All right, so now right here, chain rule. Now, this is actually going to be one of the things that's going to be the most used. So, product rule, sum rule, okay? No, product, quotient, chain. These three are going to be like just about every single upper level problem that you're going to have. So, it's the basis of all the things that you're going to end up doing. So, a couple of things that we're going to have is differentiate composite function. That's going to be one that's inside the other. That's where we get chain rules from. Power rules and chain rules, multiple composite functions. Chain rule, if a function g is differentiable at x of naught, and a function f is differentiable at g of x of naught, then the composite function of f of g is differentiable at x of naught and f of g of x of naught. So that means my starting point, whatever point there is for whatever x value, then the derivative is going to be the derivative of the inside times the derivative of the outside. You notice right here, it says just g of x, right? Yes? And on the outside is g prime. That means that I'm going to have the derivative of the inside times the derivative of the outside of it. It'll make sense here in a little bit. We're actually doing some of these right here. For differentiable functions, y equals f of u, and u is equal to g of x, the chain rule in Leibniz notation. Okay, so we're actually going to be dy of du, so I'm taking the derivative in terms of u, times u with the derivative in terms of x. Okay, yes, I believe Leibniz notation right there. I don't know if anyone cares.
I don't even know who that is.
He's the creator, original creator of calculus. Okay, not that other guy. The other guy just stole it. Anyway. All right, composite function. So, this is what it is. First thing, take the derivative of the inside. Okay? So, I'm going to say that all this is going to be the inside. So, this is going to be x3 minus 4x plus 1. And the derivative of that would be 3x squared minus 4, right? Like that. So that's the derivative of the inside. Now, the whole thing with the u is I'm going to replace all this right here, the inside, with u. So now if I rewrite that, I'm going to say that u to the 100 now this is referring to the outside of that. By using the u, I'm no longer even concerned with anything that's on the inside. Okay? So, what's the derivative of u to the 100? Very good. So, that would be 100 u to the 99. And now with chain rule, I have everything, all my parts right here. So now it's going to be this times derivative of the inside, which was right here, 3x squared minus 4. Yes?
Okay.
Okay, and now put back the u.
Define that.
Put it back in. So right now it's u, right? We use u over here. Now let's put that back in. So what does u represent?
Cube minus.
Yeah, it's that. So it's going to be 100 parentheses x cubed minus 4x plus 1 closed raised to the 99 times 3x squared minus 4. And that is my y prime. Does that make sense or is that nonsense? Chain.
Okay, so chain.
Chain. Chain. You good? Okay. Now, let's look at the next one. So we have inside and outside. So if I identify it by each part, all this right here on the inside is going to be my u. So I'm going to say that u is 3x minus pi over 4. That's my u. So I'm going to be looking for the derivative of this. That's the inside, right?
Yeah.
Derivative of the inside is going to give me just 3. So it's going to be 3. And so the derivative of the inside, let's call that a u prime. And then inside, right here, so now over here I'm going to have cosine of u. So what is the cosine of u? Negative sine, very good. So we're going to have negative sine of u, right? And this is going to be the whole thing together. So negative sine of u, so this is my y prime. So it's the derivative of the inside, which was 3, right? Times this, so times 3. And now what do? U sub back, right? So I U sub out to get this stuff here, and now I U sub back. So put the u back in. My u is 3x minus pi over 4. And I'm going to bring that 3 up front too. So y prime is negative 3 sine of 3x minus pi over 4, like that. Is that a whole lot easier? If we had 2 of these, instead of doing to 100, it would have been squared, and we would have expanded it first, and then taken the derivative of each item. That would be a pain. We don't want to do that. Because once you actually get into bigger numbers, like the exponent being 100, you don't want to expand that 100 times. So chain rule is there to actually take care of a lot of the stuff and make it simplified. Yes? No? Maybe? Possibly? Possibly. What's wrong with that?
Okay.
No, seriously. What? Negative 3. The 3's up front, right?
Yeah.
And then sine of, and all that stays inside the parentheses. This one up here, that one's kind of crazy, but the only thing you could do is just put the 3x squared minus 4 in front with the 100, or distribute that in, but leave it all piece by piece. So you could actually see each item individually. You really don't want to try and expand when you don't have to. Okay, so yeah, if you don't have to, don't do it. Just leave it alone. Because you can clearly see, hey, this one over here should be the derivative of the inside,
Yeah.
and then the derivative of the outside is this piece right here. So even like for me grading these things and looking at it, I can easily or clearly see, oh, you got that, which was the derivative of the inside correct, and derivative of the outside correct. All right, so now identify the u on this next one. What's the u? X squared minus 1. So I'm going to say that u is x squared minus 4, right? U prime. X. All right, and so right now I have e to the u, right? What's the derivative of e to the x, or e to the u? E to the u, right? Same thing. So it's going to be y prime is e to the u times 2x. And now, what do I do? And
Oh, yeah.
put it back, right? U sub back. U sub back. Because we U subbed it to change to clearly identify which pieces we're using. So we labeled it as U, got my U prime, and then U sub back. So this is going to give me y prime is going to be 2x e to the x squared minus 4. Not too bad, right? Okay. Now let's do the next one. What's my u? Or e to the x. So my u is 4 e to the x and u prime, or e to the x. So if that's my u, I'm going to say that sine of u. What's the derivative of sine? Cosine. Very good. It's a positive cosine. So I'm going to have y prime is cosine of u, right? Times 4 e to the x, and then put my u back, u sub back. I'm going to bring my 4 e to the x out front also. For e to the x, then cosine of 4 e to the x. You guys feel pretty solid about that? And just in case you did forget, okay, composite function right here, trigonometric chain rules apply. If you completely forgot, derivative, like derivative of a tangent, okay, and then, so hopefully this will be helpful. Anyway, but I'm going to leave off right there. We're not going to start this one until tomorrow. So make sure you guys all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff for the merch store.